Today is a beautiful day for science. Currently, we are seeing multiple M-class flares coming from region 3089, beginning at 1214 UTC with a M7 2.7, followed by a 5.44, then a 3.65, then a 1.88 for M-class flares, distinguishable on the region 3089. Meanwhile, region 3088 also is showing a lot of activity as they continue to have the battle of the flares. 3088 remains second fiddle for 3089, as 3089 steals the show with the most significant flares of the day. Yeah, we can zoom in a little bit more. Currently, these flares that are occurring, they are just transmitting a high amount of energy of light. So when a flare occurs, it's as long as it's in view on the Earth-facing disk, then it's reaching Earth within approximately 8 minutes. So all of these flares have impacted Earth already, and the moment we're seeing them, we're being impacted. Now, any coronal mass ejections post these events, including 3088, which we're looking at now, these, on the other hand, do appear to be not projected towards Earth. So most of this plasma displacement does appear to be going either behind Earth's orbit or ahead of Earth's orbit, depending on which region we're discussing. So looking at region 3089 on the east side of the sun, you can see how this plasma projection is going, and you can see the distinguished marks, and it is going to the behind Earth's orbit. We are in the center, going around the sun. The sun's rotation is approximately 28 days on average, and so yeah, this is going behind us. So not a lot of concern here from coronal mass ejections. That's not to say that there won't be a chance that we can get a glancing blow, so to speak, because a coronal mass ejection isn't a projectile that just fires out from the sun. It's actually a very dense compiling of collisional plasma. And as this plasma displaces and goes from the sun, it starts to spread and it expands until it's a non-collisional plasma. Good example of this is collisional plasma on Earth would be lightning, and your neon signs would be non-collisional plasma, or the aurora would be non-collisional plasma. So as this displaces from the sun, goes into space, travels, and becomes an interplanetary coronal mass ejection, ICME, it can spread up to 31 million miles. That's a third of the distance from the sun to the Earth. So we end up with a 31 million mile cloud of plasma diameter-wise. That is just this massive amount of radiation and energy that's slowly just going outward towards the outer reaches of our galaxy. What makes this wonderful is the scientists have actually developed a way that they can track these CMEs, these ICMEs, as they go beyond the Earth as well. Meaning, because they're constantly emitting a frequency of energy, they can be traced all the way till they reach out of our solar system. Now, while 3088, region 38 is what we're looking at here, this is on the west side, the west limb on the southern hemisphere of the sun. I believe that this one here is sort of biding its time. We're seeing a lot of far-reaching flaring activity, a lot of extension of those loops. And I think basically what that's showing us is that the energy is there, but it's doing it in a particular way that's not emitting as much vibrant energy at a time. And what I mean by this is we're seeing a lot of these flares occurring at a higher altitude on the sun. And the lower, closer to the surface, the more powerful the energy is going to be. You're going to get your X-class flares more significantly from lower intensities, lower to the surface intensities. And that's because, once again, as you have your collisional and non-collisional plasma, the collisional plasma is going to be more abrupt, more painful for these things as they interact. So they'll react louder, and the shout will be heard further away, and that's where you get your X-class. But as you get further away from the surface of the sun, it's not as collisional. It's got some more breathing room, so the impacts of this exchange is not as loud. So you end up with the higher amount of energy at the surface of the sun and a lower amount of energy away from the sun. And as you can see, a lot of the activity that's happening is actually at the above it, at the upper portions. And I think that's why we're seeing a lot of this energy from 3088 not outdoing 3089. Salutations, Sydney. Yeah, for some reason, I just realized my Angstrom 94 is playing in reverse, but it actually looks really cool because it goes from that reverse of pulling in the plasma as opposed to expanding it. And then we see a 131 angstroms where it's showing the hotter portions of that plasma in good detail. And yes, we are actually still in M class, and we just had a small dipple right there. Looks like, yeah, let's see where that one's at. Let's look at this in live, real time. All right, go away there, video. Thank you. All right. Oh, there's a nice loop that's expanding right here. Let's get that. There you are. So if you look right here, you'll see this loop that just stretches out right there, and it's gone. And that right there is plasma displacement. Could very well end up being a CME. Could very well end up being an ICME. Not a very large one, but one that still would be fun to trace on the SOHO satellite. And that one's going to go ahead of Earth's orbit, meaning that won't impact Earth. And this flare, this particular one here, does appear that 3088 has finally taken its stance and said it wants to be the one observed by the X-ray flux. Now the downside, despite how beneficial the X-ray flux is, the downside is it only measures the most intense reading from the sun, meaning that you can have 6, 7 flares more happening, and it's only going to really register the largest, the most significant, the one that's peaking the meter. So you can have 9 C-class flares, or 6, or whatever I said previously, and the only one you're going to get the legit reading for is the largest. So that's why I call this the battle of the flares, which one's going to be able to be allowed on that X-ray flux, which one's going to be the most significant. This most recent flare is in fact 3088.